corner, we're going to look at counting techniques, which is part of our probability unit. Now, there's some basic vocabulary that we need to know before we get started. So a probability event is just a single trial, one event involving chance. The outcome is the result of it, and the sample space is the set of all possible outcomes. Now, when you were younger, you may have made a tree diagram. And what it is it's used to systematically list all the outcomes. So if I'm looking at blood type and I want to know the different options I have, I could kind of branch them out, and this would be all my sample spaces. Now, that's not a bad idea when we have a small sample space, but if we have a bigger sample space, that might be difficult to figure out some probability events. So we have some other methods. Okay, so the first thing we're going to talk about is fundamental counting principle. And what that is the number of possible outcomes in a sample space, which can be found by multiplying the number of possible outcomes for each event. So there's more than one thing going on. So for instance, if we have a bicycle manufacturer makes 5 and 10 speed bikes, so there's 2 types of bikes there. There are 7 different colors and 4 different frame sizes. How many different bikes total can this manufacturer make? So by this fundamental counting principle, we'll take the 2 types of bikes that we have, the 5 and 10 speed, and we're going to multiply that by our 7 colors and our 4 different frame sizes. We multiply those together, and we have 56 different types of bikes this manufacturer could make. Now, a permutation is arrangement of a group of a distinct objects in a certain order. So order definitely matters. So for instance, if I want to start with the letters A, B, and C, and I want to put them in a variety of order, there are 6 different ways we can do that because, again, order matters. A, B, C, and we can switch up the B and C, and from there. Okay, so how we get to that? The first letter, when I pick my first letter of A, B, and C, I have 3 options, right? A, B, or C. Once I pick the first letter, my second letter, again, because in this case, it does not say that I can repeat anything. I only have 2 options, right? Because I only picked one. And my third letter, I only have 1 letter left. So it just gives me 1 option. When I multiply those together, I get 6. Now, in this particular problem, it's not that big of a deal to take our options and multiply them, right? 3, then 2, then 1, no big deal to get 6. But what if we had 50 options or 100 options? You wouldn't want to go 100 times 99 times 98 and so on. It would take too long. So there is something called factorial, in which it does exactly what we talked about. So for instance, in this case, 3 factorial is 3 times 2 times 1. It's just a shortcut, which we can use, which is going to make things a lot easier you can do in your calculator. So let's look at the next example. I have 8 finalists in a band competition, and how many different ways can the bands be ranked if they cannot receive the same ranking? So basically, first place, or however you want to rank them, there would be 8 options, and from there it would be 7, then 6, and all the way down the line. Okay, so what this really is 8 factorial, starting with 8 and going down 1 every time. That's what factorial means. Now, how do I do this on your graphing calculator? You can do it on your graphing calculator. You're first going to put the number that you want to work with, the 8, and then you're going to select math, and then it says PROB or PRB, and then your exclamation point, which stands for factorial, to get your answer. Now, it'll also work on your scientific calculator, in which you're going to go 8, same idea, 8 times PRB and factorial. And that would give you your answer using either calculator. Now, in the previous example, what if we wanted to know how many different ways the first, second, and third place ranking in a competition could be awarded? So first, second, and third, only the first 3 spots for these bands. So again, my first option I'd have to choose from all 8. Once one of the bands got first place, then I'd only have 7 options. And then again, going forward, I only have 6 options because in this case, I only want 3. Multiply those together, and I get 336. Now, one way you can do this, now again, this is not the way we're going to use overall, but this kind of explains why it works. There is a formula here in which at the top, I put how many options I have, and I divide that by the 8 that I have to start with and the 3 places that I want. Okay, and so from there, it simplifies to 8 factorial times 5 factorial. If I multiply those out, I could start simplifying a lot, right? So my 5s would simplify, my 4s would simplify, and from there on. And I would end up with 8 times 7 times 6, which is exactly what we did up here. Again, just kind of explaining why this works. Now, again, this isn't bad when we have a small sample space, but what if we're talking about 20 or 50 or 1,000? So we have what we can do. I'm going to show you how to use on your calculator again. Permutations. Again, this is when order matters. It does matter which one you pick first or second or third. Okay, so how we do this, I'm going to slide down. We're going to do something called combinations in just a second, and it's going to be the same key. So graphing calculator, we're going to go back to that math. And then we have PRB for probability, and then you're going to choose which one you want. Okay, and then you're going to plug in your values. Scientific, first you're going to put the N number, which I'm going to show you in just a second, the first number, how many options you have total. And then you're going to put your probability key, and then NPR or NCR, and then that last, how many do you want to pick from? I'm sorry, how many do you want to pick? Okay, so in this case, in this band case, I would have 8 total. I would have P, because I know this is permutation, and I only want to select 3. Okay, so you can practice that. You can put that in your calculator, and you should still get that 336 like you did above. Okay, so now we're going to practice with this. How many different ways can 2 students be assigned to 5 tutors if only 1 student is assigned to each tutor? Okay, so we have 5 total tutors. Order definitely matters on this one. And then we're going to select 2. Okay, I put that in my calculator, and again, you can pause the video if you want to, and then I get 20 total. Okay, our next one says, a photographer has matted and framed 15 photographs and needs to select 10 for a gallery show. How many ways can the photographs be displayed? So where they are on the wall or more than one wall is going to be important. So again, I have 15 total. My order matters. And then I have 10, I need to pick 10. Okay, that's a really big number. So I end up with 10,897,286,400 different ways that we can display those 10 pictures that we pick. All right, now we're going to shift gears just for a little bit. A combination is a selection of distinct objects in which the order does not matter. So I'm just picking some in general. Doesn't matter which one I pick first or how many when I pick the specific letter or value or book, whatever it is. In this case, it says, suppose you select 3 out of 4 books. Okay, books A, B, C, and D to use for a book report. Okay, so again, I'm going to use this. It doesn't matter which order I pick them in. So whether you select A, B, and C is the same as selecting C, B, and A for any other arrangement for these 3 books. Does not make a difference. Okay, so this is going to be very similar to our permutation, how we have it set up. But again, the difference with combination is the order does not matter. Okay, how many ways are there to choose 5 cards from a standard deck of 52 playing cards? So you put the 52 playing cards out and you just say pick 5. The order does not matter. So I have 52 total. I'm going to use C for combination. And then I'm going to pick 5. Now again, we're going to go back to how we did with permutations, and how you use your calculator is the same way, except for this time you're going to pick that combination key. Okay, I put that in my calculator, and there are 2,598,960 ways I can pick just those 5 cards. All right, let's look at the next one. A restaurant offers a total of 8 side dishes. How many different ways can a customer choose 3 dishes? How many different combinations can this customer have? So again, there's 8 total dishes. Order doesn't matter. And the customer is going to pick 3. You put that in your calculator and you get 56. Okay, let's do some here. How do using your calculator is really not that difficult once you practice a few. But now we have to identify, is it a permutation or is it a combination? So 25 students write their names on slips of paper. Then 3 different names are chosen at random to receive prizes. Is a given situation a permutation or a combination? So again, I have 25 students. 3 names are going to be picked. So the first one says choosing 3 people to each receive a no homework coupon. Now, again, you have to ask yourself, does it matter who I pick first? or I'm just picking 3 random. And again, everyone's receiving the same thing. They're all getting that no homework coupon. So that's going to be a combination because order does not matter. Okay, and the next scenario says you're going to choose 3 people to receive one of the following prizes. The first person picked is going to get a new graphing calculator. The second person picked is going to get a no homework coupon. And the third prize is that new pencil. Okay, so in this case, it does matter which order. If the teacher says, I'm going to pick my first prize now, that order does matter. So that's a permutation. Okay, let's look at the last few. 300 people buy tickets for a raffle. Then 3 different raffle tickets are drawn at random to claim prizes. Again, is it permutation or combination? So we have 300 people, and there's going to be 3 different raffle tickets picked. The first scenario says the first tickets drawn receive a TV. Then the second person gets a car. And the third person gets a trip to Hawaii. Well, that's a pretty good deal right there. So again, the order does matter. I want that trip to Hawaii myself. So again, the order matters. So that's a permutation. The next scenario says choosing 3 people to receive a gift card to a local restaurant. So again, I'm going to just select 3 people out of it. Everyone's getting the same prize. Order does not matter. So that's a combination. Okay, thanks so much for stopping by today. You have a great day.